Something extraordinary seems to be happening across our planet, and it's catching the attention of scientists worldwide. Unusual weather patterns, peculiar animal movements, and shifting geological features are sparking questions about where Earth is heading. While some changes can be linked to natural cycles, others are more perplexing, prompting researchers to dig deeper for answers. In this video, we'll explore intriguing developments in our environment, from surprising magnetic shifts to new technological tools that help us see the big picture. By understanding these changes, we can take informed steps to protect our world, enhance our resilience, and safeguard future generations. Intro Hook: The mystery unfolds. Scientists around the globe are noticing peculiar shifts in Earth's behavior that don't fit neatly into known patterns. Despite decades of research, new phenomena keep emerging. Some of these occurrences are subtle, like changes in atmospheric circulation, while others are dramatic, such as intensified storms in regions unaccustomed to extreme weather. People living in coastal cities talk about higher tides than ever before, and communities near forests witness shifting migratory routes of birds and other wildlife. These stories may sound anecdotal, but they often align with fresh scientific data. Curiosity drives researchers to gather more evidence and ask bigger questions. They launch satellites to capture real-time images of melting ice caps, use drones to map newly formed desert areas, and develop AI models to pinpoint how weather systems will evolve in the coming years. When combined, these efforts reveal patterns that suggest Earth is undergoing significant transformations at multiple levels: oceans, atmosphere, and land. Yet, this isn't about fear alone. It's also about discovery. Many scientists and explorers are excited by the opportunity to learn more about our planet's complexities. They see the current moment as a call to innovate, collaborate, and think differently. New partnerships between universities, environmental organizations, and tech companies are emerging. Together, they aim to interpret anomalies more accurately and design tools that help both city planners and rural communities adapt. The mystery captivates everyday observers, too. Curious individuals compare local weather records with what their grandparents experienced. Educators incorporate these real-world changes into lessons, sparking student curiosity about science, technology, and the future. Even casual nature enthusiasts contribute by joining citizen science projects, noting changes in their gardens or local parks. The unfolding mystery draws us in, inspiring questions and solutions that might redefine how we see Earth's past, present, and future. Alarming clues. What scientists are seeing. Across lab benches and on research vessels, scientists collect clues that point to dramatic shifts. Temperature records show spikes above historical norms, and certain plant species are blooming earlier than expected. Marine biologists document bleaching events on coral reefs more frequently, suggesting stress in ocean ecosystems. Wildlife conservationists note that some migratory birds have altered their routes, possibly in response to changes in temperature or food availability. Pieces of data, once considered isolated anomalies, now seem to fit into a larger puzzle. Technological advances help reveal these patterns. High-resolution satellite imagery provides daily snapshots of ice shelves, showing areas thinning at accelerated rates. Sophisticated sensors measure ocean currents and detect changes in salinity and temperature that can influence marine life distribution. Deep Earth monitoring instruments track minor seismic activity, offering insight into shifts in tectonic behavior. These overlapping datasets allow researchers to compare notes, form hypotheses, and identify tipping points where small changes might trigger bigger consequences. Scientists also notice that weather events, once considered rare, are happening more frequently. Tornadoes in places that rarely see them, unexpected flooding in arid regions, and prolonged heat waves in temperate zones all indicate that something is off. While climate cycles have always influenced weather, the speed and intensity of these events make scientists look for underlying causes, including human activities that release greenhouse gases and deforestation that reduces the planet's ability to regulate climate. Despite the alarming nature of these clues, the scientific community remains focused on practical responses. They share findings with policymakers to encourage measures that protect vulnerable populations. They engage with local communities, offering workshops on disaster preparedness and sustainable practices. Their goal isn't just to highlight problems, but to foster solutions. By paying close attention to the clues Earth provides, we stand a better chance of adapting effectively. The climate conundrum. Climate is a critical factor shaping life on Earth, influencing everything from the water cycle to agricultural productivity. In recent decades, researchers have documented a marked increase in global average temperatures, often described as global warming. This isn't just about hot summers. It's about gradual shifts that affect precipitation, vegetation zones, and even ocean currents. Warmer seas can spawn more powerful storms, and drought in certain regions can lead to food shortages if local agriculture isn't adaptable. Observers sometimes mistake short-term weather patterns for climate change. A cold winter can cast doubt on overall warming trends, but climate experts differentiate between daily weather fluctuations and long-term shifts. By analyzing decades of data, they identify trends that point to a sustained rise in atmospheric and oceanic temperatures. Glaciers recede, permafrost melts, and some forests face unprecedented wildfires. While some warming is part of Earth's natural cycles, the current pace troubles many scientists. Greenhouse gases like carbon dioxide, methane, and nitrous oxide trap heat in the atmosphere. Human activities such as burning fossil fuels, clearing forests, and expanding industrial processes accelerate these greenhouse gas concentrations. Research shows that these emissions play a significant role in the current warming trend. Governments and organizations worldwide attempt to address the climate conundrum by regulating emissions and investing in green energy solutions. Solar and wind power have grown significantly, and some nations commit to bold targets for reducing carbon footprints. Yet, achieving global consensus remains challenging due to differing economic interests and the sheer complexity of altering modern infrastructure. Scientists remain vigilant, continuously refining computer models that predict future climate scenarios. These models allow policymakers to gauge risks and opportunities, helping them plan for water resources, agriculture, and urban development. By understanding the climate conundrum, societies can strategize for resilience, ensuring better outcomes for generations to come. Shifting poles, magnetic and geographical changes. Earth's magnetic field is generated by the motion of molten iron in its outer core. This magnetic field is not static. It gradually shifts, guiding compasses and shielding us from harmful solar radiation. In recent decades, scientists have noted that the North Magnetic Pole is drifting faster than usual, moving from the Canadian Arctic toward Siberia. This shift doesn't sound dramatic unless you rely on accurate positioning systems, which global navigation and many scientific tools do. Beyond magnetic shifts, physical changes in the polar regions also draw attention. Satellite data reveals significant ice melt in both the Arctic and Antarctic, contributing to rising sea levels. As ice shelves thin and break away, ocean currents can adjust, impacting marine ecosystems and the climate. Wildlife like polar bears and penguins feel these changes firsthand, experiencing habitat loss and shifting food supplies. Researchers question what might happen if the magnetic poles were to flip, a phenomenon that has occurred in Earth's distant past. Such a reversal would affect everything from animal migration patterns to technology that depends on stable magnetic references. While a flip might not happen soon, The accelerating drift prompts a closer look at how prepared we are for potential disruptions. Satellites can track magnetic field variations, but updating navigation systems and flight routes might be necessary if changes become more pronounced. Local communities near polar areas already adapt to environmental transformations. Some Arctic residents notice permafrost thaw, which threatens buildings and roads. Others observe new fish species migrating northward, offering both opportunities and challenges. Governments and researchers collaborate with indigenous groups to collect valuable knowledge of these landscapes, ensuring that policies consider both cultural traditions and contemporary science. Shifting poles, both magnetic and geographical, remind us that Earth is dynamic. Understanding these shifts enables us to plan accordingly, protecting ecosystems and sustaining human activities in polar regions and beyond. Oceans in flux. Oceans are vital to life on Earth, acting as a climate buffer by absorbing heat and carbon dioxide. Yet, as atmospheric carbon levels rise, oceans become more acidic, threatening coral reefs and other marine organisms that depend on stable pH levels to build shells and skeletons. At the same time, warming waters can cause fish populations to migrate to cooler regions, disrupting fishing industries and coastal communities that rely on predictable catches. Sea levels are also on the rise, driven primarily by melting ice sheets and the expansion of warming seawater. Low-lying nations and coastal cities see more frequent flooding, especially during high tides and storm surges. Some communities are investing in seawalls and other protective measures, while others contemplate strategic retreat from vulnerable shorelines. Experts stress the importance of robust environmental policies and sustainable coastal development to mitigate these risks. Researchers use a range of technologies to monitor ocean changes. Buoys fitted with sensors measure temperature, salinity, and current strength at various depths, while satellites track sea level changes and map large-scale current shifts like the Gulf Stream. This data offers insight into how ocean circulation patterns might evolve, influencing global weather and climate. Even subtle changes in major currents can reshape rainfall distribution and hurricane formation. A key lesson is the interconnectedness of our planet's systems. What happens in the ocean doesn't stay in the ocean. It has repercussions for agriculture, weather, and even health. Warmer sea surface temperatures can contribute to stronger cyclones, and changes in fish migrations can impact food availability worldwide. Efforts to address these ocean challenges often emphasize cutting carbon emissions, but they also include restoring coastal habitats like mangroves and wetlands, which help buffer storms and absorb carbon. By understanding the ocean's flux, societies can better protect marine life and maintain healthy coastal communities. Anomalous wildlife behaviors. Around the globe, animals are making surprising detours, adjusting their breeding seasons, or appearing in places they've never been seen before. Birdwatchers notice certain species arriving earlier in spring or not migrating at all if winter temperatures stay mild. Bees and other pollinators, crucial for our food supply, sometimes struggle with shifting flowering times, leading to mismatches between plant blooms and pollinator activity. Marine creatures like whales and dolphins may also alter migration routes in response to temperature changes or shifting currents. Many wildlife experts connect these behaviors to environmental pressures. Habitat destruction fragments ecosystems, forcing animals to adapt or relocate. Climate shifts can change the availability of food and water, compelling species to venture into new territories. In some cases, invasive species take advantage of these changes, outcompeting native animals and disrupting delicate ecological balances. Scientists study these changes through advanced tagging technology, GPS tracking, and long-term monitoring programs. Citizen scientists also contribute by recording sightings of birds, butterflies, and other creatures, which helps researchers gather large-scale data in real time. The results often point to a planet in flux, as habitats shift, so does wildlife behavior, with some species adapting more readily than others. Not all the news is dire. Conservation initiatives have helped certain endangered species rebound by preserving habitats and managing human-wildlife conflicts more effectively. Wildlife corridors and protected areas allow animals to move safely, while restoration projects aim to bring back critical ecosystems. Communities embracing sustainable agriculture and responsible tourism also foster a healthier relationship with local fauna. These anomalies in wildlife behaviors serve as signals that broader environmental shifts are underway. By paying attention to these signs, scientists, policymakers, and everyday citizens can make better decisions about land use, conservation strategies, and the future of our shared home. Air quality and atmospheric oddities. Air quality has a direct impact on health, agriculture, and the stability of our climate. In many urban centers, increasing emissions from vehicles and industries contribute to smog, making it harder to breathe and prompting health advisories. Meanwhile, in agricultural regions, shifts in wind patterns can disperse pollutants over long distances, affecting communities far from the source. High levels of airborne particles can also damage crops and hinder plant growth by blocking sunlight. Scientists observe unusual patterns in atmospheric circulation. Jet streams, which guide weather systems in the northern hemisphere, sometimes loop in unpredictable ways, causing persistent heatwaves or long stretches of cold weather. Researchers link these unusual jet stream behaviors to rapid warming in the Arctic, where less ice changes temperature gradients and influences air currents. The result can be extreme weather events that linger longer than expected. Pollen seasons are also changing. Warmer temperatures and elevated carbon dioxide can increase pollen production, aggravating allergies and respiratory issues. This has prompted healthcare professionals to warn patients about prolonged allergy seasons and to prepare for more frequent asthma attacks. Monitoring stations across continents measure pollen levels, helping scientists and local governments predict surges and guide public health strategies. Some regions face unique challenges with air inversions, where warm air traps cooler, polluted air near the ground, leading to spikes in smog and harmful particulate matter. Communities in valleys or basins can experience these events more frequently, prompting local regulations to reduce emissions during critical periods. Innovative technologies like air purification towers, green roofs, and the electrification of public transportation aim to tackle these issues head-on. As atmospheric dynamics become less predictable, collaboration among climatologists, health experts, and city planners becomes essential. By addressing air quality concerns now, societies can improve public health, protect agriculture, and contribute to the broader goal of stabilizing Earth's climate systems. Extreme weather events. Extreme weather events are on the rise, challenging infrastructure, economies, and daily life. Hurricanes grow in intensity and hold more moisture, leading to heavier rainfall and severe flooding. Some regions, once accustomed to mild rainy seasons, face torrential downpours that overwhelm drainage systems, causing landslides and agricultural damage. Elsewhere, droughts become more prolonged, stressing water supplies and increasing the risk of wildfires. Scientists connect many of these extremes to changes in the global climate. Warmer seas fuel stronger storms, and shifting atmospheric patterns can lock weather systems in place, intensifying their impact. In some places, two or more extreme conditions can collide, like drought preceding a major storm, creating a cycle of vulnerability. When the land is dry and deforested, heavy rains run off quickly, causing floods or mudslides in areas already weakened by drought. Emergency responders are adapting to these new realities. Communities prone to hurricanes or typhoons improve building codes, reinforce critical infrastructure, and create evacuation plans. Fire-prone regions develop early warning systems, deploy firefighting aircraft faster, and encourage homeowners to use fire-resistant materials. While these strategies are helpful, the growing frequency of extreme events stretches resources and budgets, highlighting the need for more sustainable long-term planning. Insurance companies also keep a close watch on extreme weather. Rising claims for flood, storm, and fire damage lead to higher premiums or even withdrawal of coverage in high-risk zones. This economic pressure can push communities to invest in better resilience or relocate altogether. Engineers, architects, and urban planners collaborate on designing structures that can withstand stronger winds and heavier rainfall. Social support networks play an important role. Volunteer organizations, charities, and neighborhood groups often step in to assist recovery efforts, underlining the power of community solidarity. As extreme weather events become more commonplace, fostering collective resilience through planning, innovation, and cooperation becomes vital for minimizing human and economic losses. Technological insights, tools that uncover the strange. Technology is a game changer for understanding Earth's evolving environment. High-resolution satellites orbit the planet, collecting data on everything from sea surface temperatures to forest canopy health. These images, refreshed in near real time, help researchers map disasters like hurricanes or wildfires and study long-term phenomena such as glacial retreat. Meanwhile, drones equipped with specialized sensors can inspect remote areas, relaying information about deforestation, wildlife presence, and water quality. Artificial intelligence, AI, takes data analysis to a new level. Algorithms can sift through massive datasets to detect patterns and make predictions about future events. AI-driven models forecast heat waves, track pollution plumes, and even predict the migration of species under different climate scenarios. By identifying connections that might elude human observers, AI speeds up research and helps governments and organizations act faster. Citizen science apps let everyday people become data collectors. With a smartphone in hand, anyone can report sightings of invasive species, take pictures of unusual weather, or measure local air quality. This crowdsourced information, when combined with professional research, paints a more detailed picture of environmental shifts. Real-time data also helps local authorities respond more effectively to events like floods or disease outbreaks linked to environmental changes. Underwater robots and submersibles explore ocean depths, gathering clues about coral health, deep-sea currents, and marine life seldom seen by humans. These mechanical explorers are crucial for studying vast areas of the ocean floor and capturing video evidence of changes in ecosystems that have remained stable for centuries. On land, sensor networks monitor soil moisture, temperature, and seismic activity, providing insights into droughts, agriculture readiness, and earthquake risks. Surprising geological activities. Earth's surface constantly evolves due to tectonic shifts, volcanic eruptions, and processes like erosion and sedimentation. Although these forces generally move slowly, researchers notice accelerations in certain areas. Seismic activity in regions traditionally considered low risk can catch local populations off guard. Some scientists wonder whether changes in climate, such as melting glaciers, might redistribute weight on Earth's crust, potentially influencing seismic and volcanic activity in subtle ways. Volcanoes, long studied for their dramatic eruptions, provide further insights into our planet's internal processes. Satellites observe volcanic plumes, measuring sulfur dioxide and ash releases. When these particles reach the atmosphere, they can temporarily cool global temperatures by reflecting sunlight away. At the same time, ground-based sensors monitor tremors and gas emissions around volcanic sites to issue warnings of possible eruptions. Communities living near active volcanoes increasingly rely on real-time data to decide whether to evacuate or stay put. Sinkholes appearing unexpectedly in urban or rural settings add another layer of intrigue. Often triggered by water dissolving underground rock, they can also be exacerbated by human activities like over-extraction of groundwater. A sudden collapse can swallow roads, homes, or fields, prompting discussions about better land use planning. Engineers explore new methods to detect and stabilize vulnerable ground before disasters occur. Geologists frequently collaborate with other specialists, climatologists, hydrologists, and urban planners, to interpret how surface and subsurface changes interact. Understanding these processes is vital for designing resilient infrastructure. For instance, reinforced foundations and careful zoning can minimize earthquake damage, while monitoring aquifers can reduce the risk of sinkholes. The human factor, our role. Human activity has transformed natural landscapes on every continent. From sprawling cities and highways to vast agricultural fields, our footprints are evident. Deforestation diminishes habitats and disrupts water cycles, leading to soil erosion and loss of biodiversity. Industrial processes and vehicle exhausts release greenhouse gases into the atmosphere, contributing to the rapid changes scientists observe. Plastic pollution in oceans and landfills underscores how our consumption habits impact ecosystems far and wide. Yet human beings also have the power to drive positive change. Conscious choices about energy sources, opting for solar or wind over coal, can reduce our carbon footprint. Recycling programs in cities and towns help cut down on waste, preventing plastics from entering rivers and oceans. Responsible farming techniques, like agroforestry or regenerative agriculture, restore soil health while maintaining crop yields. These solutions highlight our capacity to live more harmoniously with nature. Individuals often feel overwhelmed by the scale of environmental challenges, but collective action has a tangible impact. Grassroots movements advocate for cleaner air, safer water, and protected forests, encouraging governments and businesses to adopt greener policies. Many corporations now prioritize sustainability, recognizing that consumers value eco-friendly products and services. Farmers learn new methods to safeguard pollinators, fishers adopt sustainable catch limits, and local communities protect wetlands to reduce flood risks. Education plays a huge role in shaping environmental awareness. Schools integrate climate science and ecology into curricula, inspiring students to become the next generation of problem solvers. Online resources offer tutorials on composting, reducing energy usage, and creating wildlife-friendly gardens. Small actions, like carpooling, switching to LED bulbs, or planting trees, add up when millions of people participate. Bright innovations changing the game. Creative minds across the world develop technologies that aim to tackle environmental challenges. Renewable energy stands out, with solar panels becoming more efficient and affordable each year. Wind turbines, once limited to specific locations, now benefit from better designs that capture more energy even at lower wind speeds. These developments help nations rely less on fossil fuels, cutting carbon emissions and air pollution. Battery storage solutions grow in capacity and durability, letting communities store excess renewable energy for use at night or during peak demand. Innovators also focus on capturing carbon dioxide directly from the atmosphere. Emerging direct air capture machines filter out CO2, which can then be stored underground or used in the production of carbon-neutral fuels. While the technology is still in its early stages, it holds promise for tackling emissions that are hard to eliminate otherwise. Reforestation and afforestation projects complement these high-tech solutions, as newly planted forests serve as natural carbon sinks. In cities, engineers design smart buildings that optimize energy use, automatically adjusting heating and cooling systems based on occupancy and outside temperatures. Green rooftops covered in vegetation reduce the urban heat island effect while improving air quality. Some cities integrate bike sharing and electric public transport to reduce congestion and pollution, supported by real-time apps that guide commuters to the quickest, most eco-friendly routes. Agriculture also sees breakthroughs. Hydroponics, vertical farming, and precision agriculture reduce land use, water consumption, and chemical inputs. Farmers use drones to monitor crop health, applying fertilizer only where needed. Gene editing techniques explore the possibility of developing more resilient crops that can withstand changing climates without heavy pesticide use. These bright innovations capture the human spirit of problem solving. By scaling up successful projects and encouraging creative thinking, we move closer to a sustainable balance between economic growth and environmental stewardship.